All right, this is a video covering fractions and their relationship to division, and also how we can compare fractions, particularly fractions that don't necessarily have the same denominator. If you haven't watched the videos leading up to this on fractions, I would highly recommend so, just because they give a little bit more clarity on how to understand fractions in general. When we talk about a fraction, we mean that the denominator, b, the bottom number, that tells us how many segments to break up our unit. So if we're on the number line, if we have a over b, then we need to break up each unit of 1, because the number line is divided in units of 1, 0 to 1, 1 to 2, so on, into that many segments. If the denominator was 5, then we would break up each unit of 1 into 5 segments. And then our numerator, that tells us how many of those segments we're talking about. So if we had the fraction 3 over 5, then what we would mean is we divide that length of 1 into 5 little parts. And then 3 of those 5, that's how many we're actually talking about if the fraction were 3 over 5. Now, when we talk about division, what we're referring to is a divided by b. A is some length, and we're dividing it into b segments. And we're going to see that these are actually the same thing. So let's start off by taking a look at an example here. We have 3 divided by 4, and we're going to show that that equals the fraction 3 over 4. To start off with, here's our unit from 0, it's not marked, but 0 to 1. And since 4 is our denominator, that means we need to divide it into 1, 2, 3, 4 segments. Once we've divided it into 4 segments, we're talking about 3 of those segments. So 1, 2, 3. So this point on our number line is 3/4 of the way to 1, which equals 3/4. Now, when we're asked to divide 3 into 4 segments, well, 3 as just thinking of it as 3 ones cannot easily be broken into 4 segments because there's less than 4 parts. However, we can also interpret 3 as the number 12 over 4. And when we do this, this makes it a lot easier to imagine what 3 divided by 4 looks like, because we're now defining 3 as 12 over 4, which equals 3, right? If we have 4 segments and another 4 and another 4, that's 12 total, and that gets us to 3 on the number line. Well, out of those 12 segments, it's very easy to divide them into 4 equal parts. If we have 12 segments here and we need 4 equal sections, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Each segment would consist of 3 segments. And since each one of those segments, there's 4 segments between 0 and 1, then 3 of them would be right here. So this is 3 divided by 4, which is obviously the exact same place as our fraction 3 over 4. Another way to look at this is a little bit more arithmetic-based. 12 over 4, which is the same thing, that equals 3. 12 over 4 means 12 segments that each have a length of 1/4. So 1/4 plus 1/4, and so on and so on and so on. And I've kind of grouped it with parentheses. The associative property of addition says that how we group things doesn't change the outcome. So I've grouped these 12 segments that are each 1/4 of a length into 4 equal parts, because we're dividing 3, which is 12/4, which is what I have here, dividing 3 by 4. So I'm saying make 4 equal segments out of the number 3. Well, that's what I've done, and you can see each segment is 1, 2, 3, 3/4. Therefore, 3 divided by 4 equals 3 over 4 as a fraction. Now we need to talk about comparing fractions. Comparing whole numbers is pretty easy. If I asked you which is bigger, 4 or 7, you would say, oh, of course, 7 is greater than. We use this little symbol to show that it's bigger. This opening is bigger than here, so 7 is bigger than 4. And we know this, I think, kind of intuitively, but we also know it because 7 is further to the right on the number line than 4 is. And as we move to the right on our number line, we're increasing in quantity. And before I go into fractions, I want to pause real quickly because we're going to need this. If A, some number, is bigger than B, if we know, no matter what A is, if we know it's bigger than B, then we know that if we multiply A by something, and we multiply B by the same thing, then A times that number is going to be bigger than B times that number. For example, let's say that A equals, 3, and let's say that B equals 2. 3 is clearly bigger than 2. Well, now, if we multiply both 3 and 2 by the same number, let's say we multiply both of them by 5. Well, what is 3 times 5? That's 15. That's still going to be bigger than whatever 2 times 5 is, which happens to be 10. So we're going to use this concept in a second, and I think that's probably a little bit obvious, but I just want to make sure I point it out. So if we're dealt with the situation of which fraction is bigger, 2/3 or 4/7, well, this is really difficult to compare, because this is saying 2/3, but a third is a different length than a seventh. So we can't just say, oh, well, 2 is smaller than 4, therefore this must be smaller, because this is 2/3 versus 4/7. We're comparing apples and oranges. They're two different lengths. So that in and of itself doesn't tell us which is bigger. And yeah, we could draw it on a number line, but that gets really tedious and difficult to make sure we're perfectly spacing out 3 segments and 4 segments. And there's an easier way to do this. For an illustration, I'm going to say, well, if we're comparing two numbers that have the same denominator, 14/21 versus 12/21. Well, 14/21 simply means 14 segments that each have a length of 1/21. So 14 is our coefficient. 14 segments that are each a length of 1/21. And if we say 12/21, we mean 12 segments that are each a length of 1/21. Or 12 times 1/21. And now that we're talking about the same length, now that we know that we have 14 segments and 12 segments, and the segments are the same length, they're each 1/21, then we can simply look at that coefficient and say, well, if we have 14 of something, it must be larger than if we have 12 of the same thing. And that's that thing I was talking about a second ago, of how if you have some number times a multiple and some other number times the same multiple, then the original number, that coefficient, is still going to be bigger than the second number. And hopefully that's a little bit obvious. If we have 14 segments versus 12 segments, and all of them are the same length, then 14 of them must be longer than 12, because 14 is bigger than 12. So moving along, we can kind of change this a little bit. We talked about in the previous video the idea that if you have 2 groups of 7 and 3 groups of 7, that's the same thing as 2/3. It's still 2 groups over 3 groups. Well, what is 2 groups of 7? Well, that's 14. And what is 3 groups of 7? Well, that's 21. So 14/21 equals 2/3. Now over here, I'm going to apply the same logic. I'm going to say, well, 4/7, that's the same thing as 4 3s over 7 3s. It's still 4/7. And well, what is 4 3s? Well, that's 12/21. I'm sorry, that's 12. And what is 7 3s? Well, that's 21. So what we've done is we have just created an equivalent fraction. We've said, hey, 2/3 is the same thing as 14/21. And 4/7 is the same thing as 12/21. But in doing so, we've created 2 fractions that have the same denominator. This fraction is talking about 1/21, and this fraction is talking about 1/21. The only difference is 2/3, well, there's 14 segments that are 1/21. And 12/21, well, that's only 12 segments that are the same length as this. So if there's 14 and 12, and we're talking about the same measurement, then 14 of them must be bigger than 12 of them. And therefore, that means that 2/3 must be bigger than 4/7, because this is equivalent to 2/3. We proved that right here. And 12/21 must be equivalent to 4/7. We proved that right here. So this brings us to an important little algorithm, a cool little trick. If you've got 2 fractions, you've got A over B, and we're trying to compare that to C over D. And since this denominator is different than this denominator, we know it's going to be difficult to compare. But the commutative property of multiplication says the order that we multiply doesn't matter. So the logic is, okay, well, let's just multiply this by this guy's denominator, and let's multiply this by this guy's denominator. So now I have the same denominator, BD, BD. Voila, we have equal denominators. But if I'm going to multiply this denominator by some amount, now I have B groups of whatever this size is. I also have to multiply this by that same number. In order for this to stay equivalent, I have to have A groups of D and B groups of D. And the same thing applies over here. If I'm multiplying D by B, then I've got to multiply C by B as well. So I have C groups of B over D groups of B. So now these are still the same thing. This is still A over B, and this is still C over D. But they have a like denominator, and therefore I can now compare these fractions. So I give a couple of examples, and I'm going to walk through one of them with this just to make sure there's no confusion. The A over B that we were talking about right here, let's say that that is 3 over 4. So 3 over 4. And we're trying to compare that, I don't know, is that bigger or smaller than 5 over 8? I'm comparing, not subtracting. Okay, well, they don't have like denominators. So 3 of 1/4 versus 5 1/8, that's really difficult to compare because they're different sizes. However, what I can do to make this a lot easier is I can say, okay, well, I know that if I multiply 4 times 8 over here, since that's this denominator, and I multiply this times 4, then now I have 4 times 8 and 4 times 8. Well, what is 4 times 8? Let's see. 8 plus 8 is 16. 16 plus 16 is 32. So I've got 32. And I've got 32 over here. Great. Now I have like denominators. But so that we don't actually change the meaning of the fraction, if I have 4 8s here, then I need to also have 3 8s here. So that I still have 3 over 4. I've got 3 8s over 4 8s, but it's still 3 over 4. Okay, well, what is 3 over, what is 3 times 8? Well, that's 24. So 3 over 4 is the same thing as 24 over 32. And over here, well, I multiplied this denominator by 4, so I have 8 4s. Well, I need to have 5 4s, right? So that I still have 5 over 8. All right, great. Well, what is 5 times 4? Well, that's 20. And now suddenly, if I've got, a segment that's 1/32 in size, if I have 24 of them, that's got to be bigger than if I have 20 of them, because 24 is bigger than 20. And this is a way that we can compare. And this is also going to become really important when we're adding and subtracting and doing a bunch of other stuff with fractions too. I hope that helps. Check out some of the other videos. Thank you so much.